Um, Welcome everybody. This is a preview of the session I'm doing at SQLBits. So if you do come to SQLBits, don't bother coming to see my session at SQLBits. It will be this. And indeed, looking at the title of this session, you might be thinking, oh, I know there's free beer and free pizza, but this sounds like a very dry subject. Trust me, it's actually really, really exciting. You will learn something. I learned stuff by even just putting this together. And I put it together from blog posts that I've already written. So there's always something new and interesting to learn about this. What we'll be learning about? We will be learning about why this is important. We will learn about how semantic models use memory and how memory is managed. We will learn about how to measure that memory management or that memory usage. And we'll talk a little bit about import mode refresh and finally look at query memory usage. But let's start with the most important question. Why do I care? Sounds very theoretical, sounds very boring. There is a really important reason why you care about this. Who's seen one of these? So this is only what one of the errors will look like. But if you've ever seen one of these errors and then clicked on see details, and then thought, ooh, wow, this seems really complicated. This is what I will hope to explain tonight. These memory errors come up fairly frequently, especially if you're dealing with big, complex semantic models and reports, and people get very confused about what they can do to solve them. I will put my hands up. I work at Microsoft, and yes, you could probably do a little bit better with the error messages. We're working on that. But more importantly, what can you do to solve them? What can you do to actually prevent these things happening? Okay. So, what do we need to know? First of all, we've got to do a little bit of theory, but it will only be a tiny little bit. We need to understand how semantic models use memory. Now, most of the demos will be done in the Power BI Fabric service on an F2 capacity. Some of the demos, because I did them on the train on the way up, will be in Power BI Desktop. But more or less, it all works the same way as far as an individual semantic model goes. Inside your semantic model, there are two types of thing that can be in memory. There is the data associated with your semantic model, all of those tables, columns, and relationships, and the things that go with them, like dictionaries, stuff that makes it all go fast and allows you to find the data you need. That's the big blue box. And there is also other stuff that goes along with a semantic model. If you're using row-level security, there'll be things in memory to do with row-level security. There will be caches. You run a query, it's slow, you run a query again, the VersaPack cache kicks in, but there's a cache in memory that uses memory. So, two big groups of things that can be in memory for your semantic model. Now, within these two groups, stuff that is in memory can be evictable and non-evictable. Evictable means we can push it out of memory if we need to. Non-evictable means that we can't push it out of memory. Why is it likely to be non-evictable? Probably because it's being used. Everything could potentially be evictable, but if it's being used, for example, by a query, then it has to be in memory. So that's when we'll be talking a lot about evictable and non-evictable stuff and things being paged in and out of memory. But basically, everything is potentially evictable, except if it has to be in memory because we're using it. Now, queries themselves also consume memory, but we're not going to talk about them just yet. We will focus purely on semantic models, how they use memory, and the types of errors that we might run into there. So, how do different flavors of semantic model, different storage modes work? First of all, let's talk about import and direct query mode models, because they behave pretty much the same. The only real difference between import mode and direct query mode models is that direct query mode models don't actually have any data in them, because every time you run a query, it gets the direct query mode model, goes away and gets the data from the direct query source, the relational database or whatever you're using. As a result, direct query mode models tend to use not very much memory, and you don't really need to care about them for the first group of errors and issues and things that we're going to talk about. But import mode models, which you're probably all using, yeah, they have data and they have all of this other stuff caches in memory. So if we think about the Power BI service, well, as the saying goes, the cloud is just somebody else's machine. And the Power BI service, Fabric service, or capacity, or if you're not using a capacity, just what's called shared, the Pro. That is all just some machines that we at Microsoft run. And your semantic model will be on one of these machines with lots of other semantic models. Now, the Vertiback engine that the import mode models use is an in-memory engine. You can back these up to disk. There's disk on these machines in the cloud. And all of these models will start off in an offline state. They will be stored on disk somewhere on these machines. Now, when somebody comes to run a report, DAX queries are generated. Those DAX queries are fired off against a semantic model, and the Power BI service wakes up and says, oh, well, I've got to get that model up into memory in order to be able to query it. So your import mode model needs to be paged into memory from the offline copy. There are two potential formats that can be used for an import mode model, or indeed a direct query mode model. There is the small semantic mode model format, and then there is the large semantic mode model format. The small one, as the name suggests, is for small models. If you ever want a semantic model to grow larger than 10 gigabytes, you've got to use the large model format. And indeed, there are probably some advantages for using the large model mode format, even for the slightly smaller models. The difference is the small mode models are stored in an ABF file, the backup file that the analysis services Vertiback engine uses. And when you query a small model, the whole thing gets rehydrated and put into memory before it can be queried. Doesn't matter because it's a small model, so that'll be nice and fast. Large import mode models will get partially loaded into memory. The engine will have a look at the queries and measures and relationships that need to be brought into memory, and it will get just the bits that need to be in memory to run the query. Models are made up of tables, tables are made up of columns, and in the background, columns are made up of, stored as one or more segments, and it's the individual segments that will get loaded into memory. Generally speaking, in fact, I'm told pretty much always, when you run a query and the query touches or uses a column in some way, either because you've explicitly used it in your query, or because a measure uses it, or because you're using a relationship where the column is involved. If you're using that, well, pretty much I'm told, in almost all cases, all of the segments for that column will get loaded into memory. So we can say that an entire column will get loaded into memory, even though strictly speaking, it's the individual segments that are loaded into memory. And once that has happened, maybe stuff will get paged out again. Because guess what? Like I said, we've got all of these semantic models sitting on a server that we at Microsoft run, and there's loads and loads of those semantic models on there. You want to know the secret of why Power BI Pro, for example, is so cheap compared to everybody else? It's because all of everybody's semantic models all sit on this cluster of machines, And guess what? When you run a query, your model gets loaded into memory and it's queried. And then maybe when somebody on the other side of the world runs their query, well, maybe on the same machine, a different model will get loaded into memory. Now, there's a finite amount of memory on these machines. We can't have everybody's semantic models all in memory at the same time. But, you know, you're running your queries now, and somebody in Vietnam runs their queries in the middle of the night. Well, guess what? We can use the same machine potentially, and it will balance out. And there's all kinds of special magic that goes on to make sure that semantic models are rehydrated on machines that aren't busy, so we can balance things. It's just very, very efficient use of hardware. If things are paged out, they will be partially paged out. Maybe one column or maybe just a few segments of a column will be paged out, reduce the overall memory usage of the model. Might be the whole thing that gets paged out. Small models are always paged out completely, but large models may be partially paged out. How do we know which columns will get paged out first? Each column has a property, which we'll see in a moment, called a temperature. And that temperature rises when it gets used. If it doesn't get used, it will slowly decrease. And it's going to be the model, the columns with the lowest segments with the lowest temperature, which are going to be the ones that probably get paged out. Just a very quick demo. Probably should have done this. I'm going to have to do my demos from over here. But if we have a look in the Power BI service on the model itself, if I have a look at, I've got a model here and I go to, come on. Right, redraw. Okay, so if I take a semantic model like one of the ones I'm going to use for my demos, like model memory demo here, and we have a look at the settings pane, this is the one that determines whether it's a large model or a small model for an import mode model. Okay, we'll come back and do a few more demos in just a moment, because some of you might be thinking, oh, that's really interesting about import mode models being paged in and out of memory. Wasn't that meant to be like one of the selling points of Direct Lake? Because isn't Direct Lake, everybody like getting excited about Direct Lake because it's paged in and out of memory? Well, yeah, but Direct Lake models basically do the same thing as import mode models. They get paged in and out on a segment by segment basis in exactly the same way. So what is the difference between Direct Lake modes and import mode? Well, not much as far as memory usage goes. The key difference is that in Direct Lake mode, the copy stored on disk is not in some obscure proprietary format that you don't know about. It's in Delta format, which lots and lots of other things like Spark can write. So Direct Lake is kind of a little bit like import mode, but its offline copy is a Delta table. Which also means that then other workloads in Fabric, like SQL endpoints, you can query them in SQL, you can get at the same data in Python and whatever, and you know, there's lots of benefits for that. Because a Delta table doesn't have all of the things that the VertiPack engine likes to have in memory, extra things need to happen when the Direct Lake model, or bits of the Direct Lake model, are paged into memory. So there is something called transcoding, where we take the format that it's stored in the Delta table and turn it into the VertiPack in memory format. That's pretty quick. And then we also build some dictionaries on the fly to speed things up. In a lot of cases, these extra steps that happen when your model is loaded into memory are really quick. For really large Direct Lake models, they could take a couple of seconds. So if you've ever used a really large Direct Lake model, and a report's been open for a long time, and then you use it again, and it just seems to take a couple of seconds to wake up again, it's going to be stuff being paged back into memory, the transcoding happening, and the dictionary is being rebuilt. With Direct Lake, there is no refresh in the sense that you have with import mode, because refresh is building the delta table, which means that you can write a Python notebook and write it to one lake. There is a thing called refresh with a direct lake model that basically points the semantic model at the latest version of data in the delta table. A side effect of that, at the moment at least, is when you do a full refresh of a direct lake semantic model, everything will get pushed out of memory and you start again from scratch. That's quite inefficient. At some point in the future, we will be clever and know that some data hasn't changed. If that data is already in memory, we won't push that out. We tried to put something into production for doing that a couple of months ago, and then it didn't work, and then we took it away again. So it might well come back. So be aware of that. All right, so now we know how import mode models work and we know how direct lake models work. Let's have a look and see how we can actually see this paging happening. I'm going to do all my demos from over here. So watch the screen, don't watch me. So first of all, I'm going to do my demos with a direct lake model called custom model here. This model consists of a number of columns. I think it's about 10 or something, all numeric, all completely random decimal numbers, and it's got about 3.5 million rows in it. I chose random decimal numbers because this is the worst possible thing you can use for compression. So we've got a model called custom model here. And I'm going to do a refresh on it. And we've got an error. Okay, we don't like that. Well, hopefully it'll be all right. We'll see in a moment. And here we have DAX Studio. I'm going to connect to the XMLA endpoint for this. It's running on an F2 capacity, which is the smallest possible capacity you can get. And let's go to custom model. That's working, that's good. So here's our model, and these are all of our columns, 20 columns of random numbers. And there's a measure there called rows, which just does a simple count. DAX Studio includes a tool called Vertipack Analyzer. Vertipack Analyzer is built into other tools as well, like Tabular Editor 3, but the easiest thing to do is use it from DAX Studio because DAX Studio is free. And Vertipack Analyzer is the tool that you can use to see how large your model is and what's in memory and all kinds of other useful stuff. Now, I've connected here in DAX Studio, and all of the Vertipack Analyzer functionality is here on the Advanced tab. But before we do anything else, we have to have a look at File and Options and go to Vertipack Analyzer and understand that there are some interesting and important options here that you will need to know about, specifically these three. Vertipack Analyzer, when I ask it to say, how big is my model, it's going to run a bunch of queries. Some of them are DMV queries to get information about what's in memory. It's also really, really interested in how many rows there are in tables, how many distinct values there are in columns. In order to get accurate values for some of these things, you have to run DAX queries. And if you think about it, running DAX queries, what's that going to do? It's going to page stuff into memory. So if I'm going to do some demos to say, well, let's see what gets paged in and out of memory when I run this query, and then I use Vertipack Analyzer, and it just runs a bunch of queries to get distinct counts and pages everything into memory, I'm not going to get the results that I'm looking for. It's going to be very, very confusing. So the settings I've got here are settings that are going to work for Direct Lake. I am going to read statistics from data about columns and relationships, but this turns off doing this for direct query. But here for my Direct Lake model, I am only going to get statistics and information about the columns that are actually in memory. So I'm not going to run any extra queries that will potentially pull in extra columns into memory. So if I now go to DAX Studio and click on View Metrics, it's going to go and do its stuff. Hopefully, there we go. All right. And what do we see here? A whole bunch of warning triangles say that stuff is not in memory. Now, some stuff is in memory, so I am going to have a go at trying to refresh this model again, because it does need to be all out of memory in order to work properly. Come on. Hopefully you are not going to misbehave for me today. There's some demos. If we have a look at the refresh history, look at show. Guess what? I've got a memory error trying to do a refresh in this, but of course it was one of those things that worked absolutely perfectly every time I practiced this, but we will have a go anyway. So if I click on view metrics, maybe we'll get lucky and something will have pushed it out of memory. We look at the summary. Oh, okay, it's thinking that it's 470 odd megabytes, which is way, way too large. Let me give this maybe one last go. Okay. Okay. So what would have happened, I'd have run this query. I'm just saying, getting all of this, get me the distinct count of columns in values in column 1. What should have happened if I hadn't got this? Actually, maybe what I'll do is I will restart the capacity. That might cause it to go out of memory. Come on. All right, pause and let's resume it. Pausing and restarting a capacity can bounce all of your semantic models onto a different physical machine in our backend. So that might have done the trick, but I am likely to need to reconnect here. And if we go to view metrics, I need to reconnect again because it's got confused. There you are. In fact, I'm actually getting all right, one last go at this. We will view metrics. There we go. And everything is out of memory. So everything is 0, everything is yellow warning triangles. That's good. I'm going to run a query now which will get all of the distinct count of values in column 1. When I run this, it'll take a few seconds. There we go. We've got a result. But now if I go to Vertipack Analyzer and view metrics, we will see that just column 1 has got values because it's the only one that's been loaded into memory. We can see the cardinality of it. And if we scroll over to the right-hand side, you will see there is a last access column, which tells us the last time this column was touched by a query. And we've also got a temperature here. So remember, this is just some arbitrary value that will decrease. Remember that this is 962.53. If I go to view metrics again, it is now only 924.44. This will decrease. And I should have looked at this beforehand, but their total size in memory has changed again. This is just what is actually in memory right now. A really common mistake to make when you're looking at import mode models or direct lake semantic models, look at this as the size in memory. It's the amount of memory the model is using. It's not necessarily the size of the semantic model itself. Okay, so that is how we can understand what model memory usage looks like. VerStack Analyzer allows you to save that data to a VPAX file on disk, obfuscate it if you want, send it off to somebody to analyze it and look at it. Now, the next thing to understand about this is there is a finite amount of memory that your model is allowed to use. That's documented. It will vary depending on whether you're using the small model size or the large model size. It will also vary depending on whether you're using shared/pro or the different SKU sizes that you're using. There's documentation for all of this. But if your model needs to use more memory than you are allowed on that capacity that you bought, you will get an error. The good thing is that the model doesn't have to be complete. If you're using a large model or a direct lake model, the entire model doesn't often need to be in memory in order for your query to run. So what could happen is that you run your query, some stuff will get paged out, and some other things will get paged in, and your query will run fine. However, if you run a query that really forces way too much of your model, maybe the whole model to be held in memory, then you will get an error saying you've used more memory than you were allowed. We go back to DAX Studio here, and we run a query. What this does is it says, let's get the top 10 rows from source data. So every single column, the top end function is quite inefficient, so this will actually force the entire table to be paged into memory. And when I do this, I will actually get the error that I am meant to get. So it will run for a couple of seconds. And here we go. There we are. We're getting a, if I scroll down to the end, there we go. We cannot complete the requested operation because there isn't enough memory. I've got this on a slide here. But this is the error, and look for the highlighted stuff in green, that you will get when your model is trying to use more memory than it's been allowed. Tells you how much memory your model was allowed to use, and also the memory limit, which is there for an F2. Okay, so that's model memory limits. There is another error that you might run into with import mode models. With import mode models, it is actually quite hard to know how much memory the model will use when it's paged in. So there's another little guardrail that's in place. There is a maximum size on the offline copy of the model in import mode. I have seen this for direct lake, but I've been told that actually it's a bug. You should never see this error with direct lake. But for import mode models, the offline copy has a maximum size as well. Again, this will vary depending on whether you're using small or large mode, large format, and for large format, the offline copy size, I think, is the same as the maximum memory you're allowed. But basically, before stuff gets paged in, the query and you run a query, you might well find that actually we can't even page it in because we think that it's going to be too large if we do. So the error here is this maximum size limit on disk error. I can reproduce that with my import mode model here fairly easily, because what I did with my model memory demo 3 semantic model here, which is an import mode model, I built a really large model on a capacity when it was an F64, and now I've scaled it down to an F2. So it was perfectly okay for an F64, but it's a really large model. It's now stored offline. And indeed, if I try and open a report, the report will either not open at all, or I will get an error message inside the visual. Now, I was kind of guessing that it was not going to open at all anyway, but you will basically see somewhere along the line. Actually, no, I haven't got that open there. But somewhere along the line, you will see that max offline dataset size error. And indeed, I can get it here in DAX Studio by going to model memory error over here. And there we go. I can't even open it in DAX Studio. I get the exceeds maximum size limit on disk. So that's basically another way of saying your model is too large. Now, another thing that can use memory is import mode refreshes. So you've probably heard in import mode that your model might need twice the amount of memory. This is because if you've got an import mode model and you do a full refresh on it, what happens is you have the import mode model in memory, the original version. We create a copy of that model. We refresh the copy, and then when the refresh finishes, the copy is swapped out for the original. So at that final point, you've got two copies of the same import mode model, one with the old version of the data, one with the new version of the data, double the amount of memory. Why do we do this? We do this so you can carry on running queries against your existing model while the refresh is taking place. But by doing this, you might well run out of memory. So when you do semantic model refresh, the amount of memory that you're allowed to use is the maximum amount of memory that a semantic model can use, minus the amount of memory that the model was using when the refresh started. So this counts for refreshes. It also counts for some other operations, like if you're altering a cube, something that will take a, involves taking a copy and changing it. This will result in another type of error. This is called the command memory limit. Now, the command memory limit, I will not try and do a refresh here, but I have got a profiler trace taken during a refresh. All of this stuff is a refresh, all of these command begin and end events. But here, I've got an error event captured in profiler. You can capture this in log analytics or workspace monitoring or whatever you want to use. And the error message that you will get now is resource governing. This operation was cancelled because there wasn't enough memory to finish running it. If we have a look at that here on screen, it will again tell you how much memory your model was using before the command, which is the refresh, started, which was 795 megabytes, and the model then consumed during the refresh 4,344 megabytes, and it tells you the memory limit that you were allowed to use for this particular SKU. What are the things you can do about this? Well, you can do incremental refresh, because with incremental refresh, you're only reloading certain parts, certain partitions of a table where the data has changed, which means that shadow copy that's being refreshed is actually much, much smaller. So that's the really easy thing, use incremental refresh. Another thing that you can do is do what we call a process clear, which is a special type of refresh, which just pushes all the data out of the model. If you do that, model memory usage will go down to nothing because there's no data in there. And then you can do a refresh and probably only use the same amount of memory as you were using before. The downside of that is that you can't query the model during a refresh, which you might not care about overnight. But there is another cool trick that you can play, which is pretty easy to do if you've got Fabric enabled. You can use query scale out. So query scale out is a simple setting on your semantic model. Oh, there's my error. Finally came up. There you are. There's the maximum size on disk error. So let's go back to here. But then if we go to, I'll just go to this one indeed and have a look at the settings. No, that was a report. So go to settings and query scale out. This is just a switch you can flick. What this does is instead of having a single copy of your semantic model on one of the servers in our backend, you can have multiple, and the Power BI service will redirect queries to multiple servers. You're probably not going to get any benefit from this unless you've got a very large model which you used a lot, and you're probably using at least an F256 or bigger. It's just, it's just not, you're not going to notice any difference. But there's a side effect of this. Now, query scale out, semantic model scale out, or whatever it's called, both in the docs, like I said, involves having multiple copies of your model. And by default, when you refresh, it will get refreshed on one server. And then when the refresh finishes, that copy will get replicated across all of the other possible servers. So that replication happens automatically, but you can turn that replication off. So what you can do is turn that replication off, do a process clear, which will remove one copy, all of the data from that one copy, which isn't going to be used for querying anyway, and then do a full refresh, and then do a manual sync, and guess what? It all just works. You can query your model, and you will never use more than one time your kind of overall model size refresh. How do you do this? I have a blog post, but the reason I say you need to use Fabric for this is that you will need to do some slightly more complex refresh. You've heard of semantic link or semantic link lab. Come on. This is like VBA for Fabric and VBA for Power BI. It basically just means that you can use a notebook inside a Fabric workspace, and you can, with some very simple code, refresh and do all kinds of advanced refresh. So here, this is all the code you need for a model that has had its manual replication turned on, do a refresh, which is of type clear values, then a refresh of type full, and then a manual replicating. 3 lines of code, and it can save you loads and loads of memory and allow you to refresh much larger models than you have ever done before. Okay. Last thing to talk about. We talked about how models use memory. We also need to bear in mind that queries use their own memory. So queries will read data from the model, but they will read compressed data, and they might need to decompress that in their own little memory space. And then they might need to do other stuff. They might do complicated calculations and all kinds of things. And that in itself uses memory. And guess what? There is a limit on how much memory a query can use. And of course, it varies by whether you're using shared or whether you're using a capacity and what size capacity you're using. Generally speaking, 10 gigabytes is the most common query memory limit. Now, if you are hitting the query memory limit when you run a query, you are doing something wrong, because no query really ever needs to hit like 10 gigabytes of memory. Well, maybe I'm being a little bit harsh. Some things like distinct count measures are always going to be very, very memory intensive. But it is much more likely that you have done something in your semantic model or your DAX or your query to consume way more memory than you probably should have done. This is what the error looks like. You will see this in that error that we saw on the first slide in a visual in your report with that resource governing error. In Power BI Desktop, you will not see any detail, but in the Power BI service, you will see this. And once again, it tells you your query consumed more memory than you are allowed. There is a default for the query memory limits. You, as an administrator, can also go in and change the query memory limit. I forgot to say you can change the max offline dataset size if you want. But here is the query memory limit. It's expressed as a percentage of the overall limit. What I did to recreate that error in the Power BI service is just set that to 1%, wait 10 minutes, and then the new query memory limit kicked in. So we are going to be using too much memory. How do we know how much memory we're using until we hit the error? Well, this is where DAX Studio comes in, or if you're using a profiler trace, something like that. So if I was to go back here and rerun my query, which only gets like one column into memory, and I turn on server timings here in DAX Studio, and I run this query, so DAX Studio, I'm sure you've all seen how to use DAX Studio to performance tune queries. There is now this execution metrics event, which DAX Studio shows you. You can see it in Profiler or like Analytics or Workspace Monitoring or whatever you want. There is going to be one of these events that happens after every query. And what it allows you to do, among other things, is see the approximate peak memory consumption in kilobytes of that query. So you can see not only how long your query runs for, you can see the peak memory usage for the lifetime of that query. This is what you care about for avoiding memory errors. So what you need to do when you are tuning is have a look at that and make sure you are not going over the limits. This is all well and good in the Power BI service, but what about desktop? You're developing in desktop. How do you know whether you're going to hit those limits in desktop? Because you've got a really meaty machine with loads of memory, and maybe you've got more memory on your desktop than perhaps is allowed in the Power BI service. Well, by default, Power BI Desktop will try and guess what limits are going to be enforced. If I go to Power BI Desktop here and go to File, Options and Settings, Options, and we go to Current File Report Settings and go down to the bottom, there is here in Report Settings a section called Query Limit Simulations, where you can specify the memory limits that are active in desktop if you want to test. So there are some presets. You can also use custom limits here. There we go. If I set a custom limit of this here, with a bit of luck, when I use, there we go, it's already given me the error. There we are. I've simulated query memory error. What are the kind of things that you need to watch out for? Well, it depends. I'm always learning new ways of consuming lots of memory for errors. Like I said, distinct counts are very, very memory hungry. There's not that much you can do about them. Complex DAX calculations and bad modeling practices are almost always the cause, though. What are the things you need to look out for with complex DAX calculations? I've got a whole series of demos, but I'm kind of out of time, so I won't do all of these things. But here in desktop, this particular visual used an error called air sales V1. And I built it to illustrate a number of things that you can do that are bad. First of all, I am adding 0 to the end of the measure. People do this a lot because they don't like the way that measures sometimes return blanks. This is the #1 worst thing you can do, because the engine has tons and tons of optimizations for calculations that return a blank value, a null value. If you add 0, in DAX, 0 plus null is 0, you add 0 to a measure, it will never return a blank, which means that all of those optimizations stop happening, then memory usage will balloon, and indeed, if you think about it, the size of a really large query result set could be even larger, because the things that were excluded because they were all blank, they're now zeros, it all explodes. So never ever do that. Similarly, I'm using filter here on an entire table. That is a very naughty thing to do there. In a lot of cases, the engine will optimize that away, but it won't always. Never ever use filter in the second argument of calculate. Never, ever, ever do it. What you should be doing is something that's maybe a little bit like that. Maybe I should use keep filters here. But yeah, you don't need to use the filter. It's even easier. You don't add 0 onto that. The third thing to watch out for is tables with loads and loads of rows on it. Your table has a vertical scroll bar. You need to scroll down. That's a bad thing, because that means somewhere in the background, a really large table is being materialized in memory. So no adding zeros, no using the filter function, the second parameter of calculate, no tables with scroll bars. Got a table with a scroll bar? Guess what? Your end users are going to have to scroll up and down. So why not use a slicer to help them navigate it? That's going to reduce the size of the result set, use the size of the table, reduce the size of the table in memory. It'll probably be more usable anyway. All right, I've gone on long enough. I've used my allotted time. To conclude, memory errors can happen to anybody, happen to the best developers. The key thing is, when you're developing, people are relatively good at doing performance testing for their refreshes or for their DAX queries, for their visuals while they're developing. Because you don't want slow reports, you don't want slow refreshes, you want to speed them up. People very rarely look at memory consumption, which means you could have nice fast refreshes, nice fast Power BI reports, which use a large amount of memory. And then guess what? You make that one small change to a calculation, or we go from January to February to March to April, and the data volumes get bigger and bigger, and you suddenly go over a memory limit, and you start getting errors, and your refreshes fail, your reports don't load at all, and bad things happen. The phone starts ringing. So when you're developing, have a look at memory usage as well. Be aware of all the different types of errors that can occur and the limits involved, and make sure you come in underneath them. Your life will be easier as a result. So, thank you very much. I can take some questions now. I think there's going to be a mini break, but I will take questions in the break as well. At the back, yes.
Okay, thank you. Very engaging presentation. So my question is, you're familiar with Tabular Editor, right? And Dark Studio, they are external tools. Now, if you create a, say, calculation group with a logic using Tabular Editor, and you have an error in that logic on Tabular Editor, it gives you the same error, this memory error. I don't know if you're familiar with that kind of situation. But
so the question is, if you create a calculation group in Tabular Editor, you're getting the same memory error that we're talking about here. So the first question is, well, which error are you getting? Because there's nothing inherently wrong with calculation groups. There's nothing inherently wrong with Tabular Editor. The problem is your calculation group is probably triggering some form of memory error, and you need to find out what that error is and what's triggering it. But there's nothing wrong with Tabular Editor or memory or calculation groups. Something about what you've done is triggering excessive use of memory. And it could well be, I mean, it might depend on where you're seeing the error. If you're seeing it in a report, it might be a query memory error. If you're seeing it, something else, maybe it's going to be like you're using too much memory, and perhaps Tabular Editor, when it's saving the model, it might do something that triggers the entire model to be loaded into memory. But there's nothing inherently wrong with calculation groups or Tabular Editor.
Thank you.
You were first, I think.
Yeah. So some of us are using tables from different sources rather than Fabric itself. So for example, we are doing data tables from Databricks, bring them in the learning catalog, and then into the lakehouse, and then that gets consumed by our semantic model. So the question that we've been sort of wondering about is, so Fabric has a bunch of different profiles which let you do with Spark either read optimize a table or write optimize a table, which makes sense. What we want to know is, if we have something coming from a completely different system, does it matter if it's write optimized over there? Or does it not matter because you maybe said that transcoding is done at a whole table level, so it will just do it for the whole table when it changes anyway?
So the question is, you're using direct lake mode. You're using direct lake mode, but on Delta data that is being shortcutted in from another source like Databricks. And Delta is not just Delta. There are going to be lots of different ways to compress and write data. In Fabric, you're right, you can set memory read optimized, write optimized with data that's come shortcutted in from somewhere else. Who knows what's going on? Well, you don't know. That's the thing. It's probably going to be okay, but it might not be. If you're using a Fabric engine to write a Delta table, we know what is going to work well with Direct Lake. It's all to do with how the data is compressed, how many row groups you've got, and things like that. And we deliberately write the data in a way that it's going to work better with Direct Lake. You don't get that guarantee with something written by Databricks, for example. But it might not matter. If it works, you're absolutely fine.
I just want a bit of clarity on if it makes sense for you to know about this answer this, that's fine. And if it's too much detail, that's fine as well. But I'm just wondering if, so when the transcoding operation happens, you can think is delta to vertipack. Does it sort of completely discard all the Z order grab?
No, it does not. It will, loading the data into memory, it will depend a lot on how it's been written to disk or whatever created the Delta table. So one last question here. Yes, sorry. So the question is the temperature time dependent or size dependent? The answer is, I do not know, and it is not documented, and you don't need to care about it. Or you can, and there's nothing really you can do about it anyway, because you can't control what's in memory or what's not in memory. But it's quite nice to know that you can see the temperature there, and you can see it slowly decreasing, and that will probably give you an idea of, if you're doing some testing to try and understand how this stuff works. It's another thing that you can look at and demo at user groups. All right, one last question.
So you had stories about memory. Is it just across your capacity, or is it across global capacity? So if there's a high load and other people have higher temperature on their data, they're sort of reloaded it and you're loaded out, or is you can get your full capacity all the time?
So the question is temperature only considered for your capacity or for everybody's data? You do not know. It is actually going to be for everybody's data, but it will vary, it will depend, we will use it for whatever. But Power BI Fabric capacities, they are not you running on your own physical machine. Everybody is sharing stuff. There are rules, there are all kinds of things going on that are not documented and not explained, but who knows? It is not going to be just your usage though. All right, that's me finished. I will not keep you from your break. Thank you very much. And if you've got more questions, I'll be around later.